Number 5. They give us this matrix M. It's A plus B plus 1, which is 6, and then 3 zeros, and then the second row is 0, C plus D is 4, plus 1 more is 5, and then 2 zeros, and the next 2 rows is this one and this one. And part A says, find the characteristic polynomial of M. Well, then that means you need to compute the determinant of M minus lambda I and set it equal to 0. That just means you take away lambda from these entries. And you do nothing to the other entries. You leave them like they are. So this is going to become 6 minus lambda. I'm going to leave the other entries the same. Not going to touch them. Triple 0, 0. I'm going to take away lambda from that one. 5 minus lambda. Don't touch the other entries. 0, 0. The 1, I'm going to take away lambda. The next entry is negative 1. 0, 0, 1. That diagonal entry, I'm going to take away lambda. And I want this determinant to equal 0. So what I can do is the following. I can take this entry, 6 minus lambda, and multiply it by this determinant, which is 5 minus lambda, double 0, 0, 1 minus lambda, which I want to double check. Yeah, that's right. And then 0, 1, 1 minus lambda. Okay. Well, this here is I'm going to do the same thing again. I'm going to take 5 minus lambda, cross off the first row in the first column, and then multiply by that determinant. So I have 6 minus lambda, 5 minus lambda. This, a 2 by 2 is easy. You multiply those two. Since they're same, it's going to be squared. Minus, now you multiply those two, which is 1. So what we get is the following. We get 6 minus lambda times 5 take away lambda times, I'm going to square that. 1 minus 2 lambda plus lambda squared plus 1. This is 6 minus lambda, 5 take away lambda times lambda squared minus 2 lambda plus 2. Plus 2. That, let me write it down because part of it you may not see. This right here, this here, that's the answer to part A. That is the characteristic polynomial. Just want to see something silly. Let me put A there for completeness. Part B is here. Part B says determine the eigenvalues. So remember, this was equal 0. So the eigenvalues are what makes each of these factors equal to 0. 6 minus lambda equals 0 implies lambda is 6. I'll call that lambda 1, the first one. 5 take away lambda is 0. That implies that lambda is 5. 5 take away 5 is 0, so we'll call that lambda 2. Now, the next one's a little bit harder. When does that equal 0? Remember, there's a 1 here. When it comes to a quadratic equation, that's A, and that's B, and that's C. So lambda is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Well, this is B, 4 times A is 1, and C is 2, divided by 2 times 1. Let us clean this up. So this mess will become positive 2 plus or minus the square root. Negative 2 squared is 4. 4 times 1 times 2 is 8, all over 2. So this becomes 2 plus or minus the square root of negative 4 over 2. But negative 4 is the same thing as 4 times negative 1. So the square root of 4 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1 is I, divided by 2. This fraction is 1 plus or minus that fraction is I. So we get 2 more lambdas. Remember, lambda is equal to this. So lambda 3 is 1 plus I, and lambda 4 is 1 minus I. So now we have the 4 lambdas. And what I'm going to need is, hope I didn't draw on it too much. Okay. So I'm going to need this equation, this matrix. And let's see how much I can play with this. So what I really want is 6 minus lambda, triple 0, 0, 5 minus lambda, 0, 0, 1 take away lambda, and 0, 0, 0, sorry, 1, 1 minus lambda. Okay. Let's get rid of that. Doesn't want to do that, huh? Okay. Now, let us try to move this over. So, in fact, this matrix, what was that? This matrix, this is m minus lambda I. Now what we want to do is, now let's not make any silly mistakes. Lambda 1 was 6. But now, if lambda is 6, 6 minus 0, 6 is 0, 0, 0, 0, 0, 5 minus 6, 0, 0, 0, 0, 1 minus 6, 0. How did I just copy down m and not get that negative 1 is beyond me. Oh, I know. I did get it. I just messed up. Okay. So this is -1, and this is 0, 0, 0. 1 minus 6 is -5. Now, I want to know when this is equal to 0, the 0 vector. Okay. Now, one thing I can do, and a lot of teachers would say to do it, is I'll move the first row to the last row. You know what? I'm going to multiply every other row by -1. Hate so many negative lines. And row 1 is going to go to row 4. So there it is. The other 3 rows, the second row becomes the first, and I multiply all the entries by 1. The next row moves up, it becomes 5, 1, and the last row becomes the next to the last row, which is that row. Okay. Now, I'm going to get this 1 to become 0 by using that 1. I'm going to say row 2 minus row 3. So row 1 is not changing. 0 minus 0 is 0. 0 minus 0 is 0. 5 minus 0 is 5. 1 minus 0 is 0. 0 minus 0 is 0. And the third row, I'm not going to change. And the last row is all zeros. And then I'm going to divide row 2 by 5. That is, this 5, it becomes a 1. Okay. So let me just erase that. This first row says that x2, that's the x2 row, equals 0. It says the second row says that x3 equals 0. The third row says that x4 equals 0. And x1 is r, any real number. That means big X, which is x1, x2, x3, x4, is equal to r times 1, 0, 0, 0. Because r times 1 gave me r1, r times 0, I meant to say r times 1 gave me x1, r times 0 gave me x2, r times 0, which is 0, gave me x3, and r times 0, which is 0, gave me x4. And I'm going to call that x1. It was associated with lambda 1, which is 6. So actually, x1, we're going to call x1 without the r, is 1, 0, 0, 0. Okay, now we're going to do the same thing with lambda 2, which was 5. Now, I hope that I have m here. There, let me just erase. Let me put it here as well. Okay. Remember, I'm supposed to take away lambda from each element on the diagonal. And lambda is 5. So 6 minus 5 is 1, and then 3 zeros. 0. Now, 5 minus 5 is 0. Third row is 0, 0, 1 minus 5, negative 1. The last row is 0, 0, 1, and 1 minus 5 is negative 4. Okay, so I want to solve this system of equations. I could interchange those two rows. That way I get my leading one right in the third row. So I have 1, 0, 0, 0. The second row I'm going to put on the bottom. So I'm now going to have this row right here. 0, 0, 1, negative 4, 0. I'm going to put this row right below it. 0, 0, negative 4, negative 1, 0. And the row of zeros on the bottom. Why did I do this? Because the first row, it has its leading entry right here. Non-zero entry. The second row has it right here. And when it came to the first one, everything else was 0 above and below. But when it comes to the second one, I have that negative 4. I'd rather deal with 1 to kill off the 4. I'll just multiply row 2 by 4. That'll put a 4 there. And then I'll add row 3 to it. 4 times row 2 is 4 times 0, 4 times 0, 4 times 1, and 4 times negative 4, which is negative 16, and then 4 times 0. And row 3 is just 0, 0, negative 4, negative 1, 0. And if I add them, I get a 0 here, which is what I wanted, and negative 17, 0. And then I'll divide by negative 17 and I get a 1 there. So oops. Okay. Let me just check this, please. I wonder where that negative 1 is from. Okay. So now that I have a little bit more room, I'm going to write down what I have. Oh, I divided by 17 and I got the 1. So first row didn't change. First row didn't change. The second row didn't change. I know, because I only said I'm changing the third row. That's why I put this by the third row. 0, 0, 1, negative 4, 0. The third row changed to 0, 0, 0, 1, 0. And the last row did not change. Okay. So first row has a non-zero entry. Above and below is 0. Second row has a non-zero entry. What's above and below is 0. Third row has a non-zero entry, but you have that 4. So what I'm going to do is I'm going to take row 3, I'm going to add 4 row 1s, because 4 of these would just be 0, 0, 0, 4, 0. And when you add it to row 3, that negative 4 disappears. Here is row 3. It is 0, 0, 1, negative 4, 0. 4 times row 1 is 0, 0, 0, 4, 0. When I add these, I still maintain my 1, but I get a 0 there. So to save a little time and space, let me put a 0 there. Okay, so now we're done. First row tells me that x1 is 0. Second row tells me that x3 is 0. Third row tells me x4 is 0. And the fifth row tells me nothing. So that means x2 is R. So big X2, because we're now working with lambda 2, is equal to R times X1, X2, 3, 4, going to equal to that. R times 0 is 0. That's what X1 is. R1 times 1. Sorry, R1 times R is R, which is what X2 equals. R times 0 is 0, which is what X3 should equal. And R times 0 is 0, which is what X4 should equal. Okay, we found X2. Now, X3 is 1 plus I. Lambda 3 is 1 plus I. So let us put back P, and remember, from every circled entry, we need to take away 1 plus I. So we're going to have 5 minus I, triple 0, 0. We're going to have 4 minus I, 0, 0. We're going to have 0, 0, minus I, negative 1. And we're going to have 0, 0, 1, negative I. And this, 0. Okay, we no longer need this. Okay. Now, how about we interchange? In the first row, this here is the first non-zero entry. What's above and below is 0. Second row, this is the first non-zero entry. What's above and below is 0. I'd rather that be in the third row, a 1. So nothing changes except interchanging two rows. Triple 0, 0, 0, 4 minus I, 0, 0, 0. Then the last row becomes the third row, and the third row becomes the last row. Negative I minus 1. Okay, 0. Now somehow I want to get this negative I to become 0. So I'm going to multiply the third row by I. 0 times I. 0 times I is 0. 0 times I is 0. 1 times I is I. And I times negative I, that's negative I squared. But I is the special number that when you square it, gives you a negative 1. So I get 1. That's R. I times row 3. Okay. And row 4 is just 0, 0, negative I, negative 1, 0. Now, when I add these, I get 0, 0, 0, 0, 0. Okay, so it just vanishes. So let me just do that right here. You want to make a new matrix for it? Fine. But it's that. Okay. So now I'm pretty much ready. I'm going to divide row 1 by 5 minus I, row 2 by 4 minus I. That's going to give me 1 followed by 4 zeros. And then 0, 1, triple 0, and then 0, 0, 1, negative I, 0, and then a row of zeros. The first equation tells me that x1 is 0. Okay. Second equation tells me x2 is 0. The third equation tells me x3 minus I times x4 is 0. That means that x3 is I times x4. So we have x1, we have x2, we have x3, and x4 is free, so it's r. It's r. So x3 is I times r. Okay, so let us write down what x equals. This is x3, and it's associated with 1 plus I. So it's r times 0, that's x1, r times 0, that's x2, r times I, that's x3, and x4 is r times 1 or r. Okay, looking good. Now, lambda 4 is 1 minus I. Okay, so that's what we need to subtract from the diagonal entries. So from 6, we take away 1 minus I. So we get 5 plus I. And then 3 zeros. And then 0. And then we get 4 plus I, 0, 0. And then we get 0, 0. And we just get I, a negative 1. And then we get 0, 0, 1, and then I. And this is all equal to 0. This matrix was helpful. Don't need it anymore. Okay. So if I divide the first two rows, the first row by this and the second row by that, I get 1, and then all zeros, and 0, and then 1, and all zeros, and 0, 0, I, minus 1, 0, and 0, 0, 1, I, 0. Okay. You can interchange row 3 and 4. How about I multiply row 4 by I? So 0 times I, 0 times I, 1 times I, and I times I, which is negative 1. And then to that, I'm going to add row 3. 0, 0, I, negative 1. Except I meant to say subtract. So then I get a row of zeros. So I have 1, 0, 0, 0, 0, 0, 1, 0, 0, 0. This row becomes a row of zeros, which I'll put on the bottom. And this row stays like it is. It just gets moved up 1. Okay. So now we need to answer this. x1, the first line tells me x1 is 0. The second line tells me that x2 is 0. The third line tells me that x3 plus I times x4 is 0. That means that x3 is negative I times x4. And x4 is free. It equals r. Any real number. So it's negative I times r. Okay. Maybe I can pull this off. Whoa. Okay. So now, big X is equal to r times something. Well, x1 is 0. I mean, this is r times 0. Well, I factored out the r. That's r times 0. I factored out the r, put the 0 in. This is negative r times r. But I factored out the r. And the last one is r, which is 1 times r. But I pulled out the r, so I get 1. Okay, that is that is x4, and it is associated with lambda 4, which is 1 minus I. Okay, now let us see what we just did. We just found the 4 eigenvalues. That is part C. Remember, we found x4 and x3 and x2 and x1. Those are the eigenvalues. Okay. Now they want us to find an invertible p. Okay. Let's see if we did it better this time. P is just the 4 eigenvectors. So x1 is, you know what, it's not going to matter, but it's in front of us. So x4, the last one, is 0, 0, negative I times 1. And x3 is right here, 0, 0, I1. Could ignore the R. 0, 0, I1. Let me confirm that. 0, 0, I1. Yes. x2 is right here. It's 0, 1, 0, 0. 0, 1, 0, 0. And x1 is, I bet it's 1, 0, 0, 0. x1 is 1 and then 3 zeros. It says it up here too. It's 1 and then all zeros. Okay. 1 and then all zeros. Now, this is part D that we are working on right now. So again, the answers to part C is that's eigenvector 1, that's eigenvector 2, eigenvector 3, and eigenvector 4. So they want us to find P and D. Well, D, that's simple. D just has the eigenvalues on the diagonal. First, lambda 1 was 6. Lambda 2 was 5. Lambda 3 was 1 plus I. And then lambda 4 was 1 minus I. Now, the question is, what is the inverse of this P matrix? Okay, and now I'm not having a column with zeros. That tells me that I made some silly calculation, or a wrong calculation, a silly one, last time. So let us find the inverse of P. It's a lot of zeros, so maybe it won't be that hard. Okay. Now, that's fine where it is. So that's P. If you want to find P inverse, what you do is you augment this with the identity matrix, and then you reduce it. Excuse me. Oh, what am I doing? Identity matrix. Excuse me. Okay. We want to reduce this. And I guess I really do want to move this over just a little bit. Okay. Well, the first row, first entry is 1. That's good. And it's a 1. And what's above and below it is 0. Great. Second row, second entry is a 1. What's above it and below it is 0. The third row, it has I. Well, if you multiply I by I, you get I squared, which is negative 1. Well, I don't want negative 1. So you know what? I'm going to multiply rows 3 by negative I, and then I'll get 1. I'm going to multiply rows 3 by negative I. Okay, so I'm not touching the first row. 1, 000. Second row, I am not touching. 0, 0, 0, 1, 0, 0. Third row, I'm multiplying by negative I. 0 times negative I. That 0 times negative I times negative I is 1. Negative I times negative I is I squared, which is negative 1. 0 and 0 times negative I is 0. 1 times negative I is negative I, and 0 times negative I is 0. Okay. And the third row, we're not touching. 0, 0, 1, 1, 0, 0, 0, 1. Okay. So, third row, we got our 1 here. But what's below it is not 0. So, what I'm going to do is, I'm going to do row 4 minus row 3. Meaning I'm not doing anything to the first three rows. So I get 1, 0, 0, 0, augmented with this. The second row is not changing. 0, 1, 0, 0. The third row is not changing. 0, 0, negative I, 0. The fourth row is 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus negative 1 is 2. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus I is I. And 1 take away 0 is 0. Okay. Looking good. Now, row 2 has a non-zero entry right here. I'm not going to make it 1 yet, but I need to kill off that 1. If I do 2 times row 2, meant to say row 3, that'll put a 2 here. Then I'll just take away the 2 from row 4. Okay, so I'm not changing the first 2 rows, so we write it down. 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. Now, 2 times rows 3. 2 times 0, 2 times 0, 2 times 1, 2 times negative 1, 2 times 0, 2 times 0, 2 times negative I, and 2 times 0. And row 4 is 0, 0, 0, 2, 0, 0, I, 0. Now I subtract. I don't think it's going to work. Well, can I extend the page? Oh, I'm able to extend it a little. So let me just raise this a little. Now I can do this. 0 take away, oh boy. Two times row 3. Okay. 0 minus 0 is 0. 0 take away 0 is 0. 2 minus 0 is 2. Negative 2 minus 2 is negative 4. Excuse me, I wanted to add them. No big deal. 0 plus 0 is 0. 0 plus 0 is 0. 2 plus 0 is 2. Negative 2 plus 2 is 0. 0 plus 0 is 0. 0 plus 0 is 0. Negative 2 plus I is negative I. And 0 plus 0 is 0. And the last row, we didn't touch. Okay. Now we're really down to the wire. Wish I had just a little bit more room. Okay. So what I am going to do is I'm going to move this matrix to the left. Perfect. Now I'm going to divide. Don't have a lot of space, so I'm just going to say rows 3 over 2 and row 4 over 2. And what I get is row 1 doesn't change. Row 2 does not change. Row 3 changes a little bit. I get 0, 0. Negative I over 2, 0. Row 4 changes a little bit. Get 1 here. 0, 0. I over 2, 0. Now that I have the identity here, this was matrix P augmented with the identity. Now that I have the identity here, that is P inverse. Okay, that is, this matrix right here is P inverse. So we need to copy this onto the next page. Okay, so maybe I'll put it right here. So P is 1, 0. Okay, negative I over 2. P inverse is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, negative I over 2, 0, 0, 0, 0, I over 2. Let's confirm that. Okay, I thought it was like that. Okay. We have a little typo here. This is I over 2, and that's 0. So that's P inverse. Let us go back and find P. P was pretty far down. X3, lambda 4. There is P. Copy. Go to the next page. Let me hit paste. And we have P. And D, and I'm going to have to move this up, it turns out. So that's P. And D was just the diagonal matrix with the lambdas on the diagonal. 6, 5, 1 plus I, and then 1 minus I. That's matrix D. Now, what exactly did they say? So, what we now know is the following, is that matrix M is equal to P times D times P inverse. That is matrix M. Rather than calculating it, maybe I could, rather than writing it down, maybe I could copy it. So, matrix M is equal to matrix P 1 0 0 0 0 1 0 0 0 0 I negative I 0 0 1 1 times, that's P, times D, which is 6, and then 5, and then 1 plus I, and then, well, that's a little bit off. 0 0 0, 2 zeros, then 1 plus I 0, and then 0 triple 0, and 1 minus I, and this mess gets multiplied by P inverse. Okay, and P inverse, oops, that could have been a disaster. P inverse is 1 0 0 0 1 0 0 0 0 negative I over 2 0 0 0 I over 2 0. And if you multiply these three matrices, you should get this one. And if you don't, please don't tell me. I really don't want to hear it. But I guess I can do a pretty quick check. I can check to see that those are inverses. Okay, that third row by the third column. Yeah, that gives you 1. And the third row, the fourth row by the fourth column should give you 1. Okay, think we have one little typo. I think P inverse should have had a 1 right there. Let us go and find that little error. Okay, it clearly says to do row 4 minus row 3, and I even put the arrows. 1 minus 0, 1 minus 0 is not 0, it's a 1. That should be a 1 right there. Okay, and then when you do 2 times rows 3 and you add 4, this should be a 1. Oops. And since that is a 1, this should have been a 1 as well. And when you divide these 1s by 2, so they just become a half, or half and a half. Sorry about that. Amazes me how I always make a mistake at the very end. So those should be your half, and this works out perfectly. This times that is the diagonal matrix, is the identity matrix. Yeah, it is. Okay, so there it is. If you multiplied out these 3 matrices, you will get M. And again, the reason they do this is if you needed to know what M to the 50 is, well, it's nothing more than P. This P times the matrix I'll write down in a moment times P inverse. And all you do is you raise all the diagonal entries to the 50, to the 50th. 1 plus I to the 50th, and 1 minus I to the 50th, and all zeros. I guess it saves an awful, awful lot of computer time doing it this way. Okay, that's all of them. I hope this is helpful. I apologize for messing up this problem when we did it live, because I said that P inverse didn't exist, and I also apologize for the video being corrupt. Please forgive me.